Hello, 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 ladies and gentlemen, statisticians. We are going to be taking notes today on comparing two means. So, eventually, we're going to be able to use the data that we collected today as we flew our paper airplanes and construct a two-sample t-test. But before we do, let's talk about some general information. Okay, so what is the purpose of this? The purpose of this test here is to compare the data of two means of quantitative variables. So remember, quantitative means quantity, which means numbers. So they have to be numbers. Like today, what did we do? We measured the distance. And as we measured the distance in inches, that's our quantitative variable from two distinct populations. What were our populations? Well, we had two different types of airplanes. We had the Condor and we had the Delta. Next, what do we compare? I'm repeating myself, but here we're comparing two distinct populations or treatments. Now, in this particular case, those populations, by doing a significance test about the difference. So what we're going to be doing tomorrow is we're going to be I'm going to give you guys the data. We're going to find the mean rather of one sample, the mean of another sample, and then looking at the difference between them. So as we continue, what are the facts we need to know? Well, we need to know what the mean is, which we know is the middle line right there. We need to know the standard deviation, okay, which is the distance from the mean to that point on the graph. And we need to know here are the different values of the various distributions. So let's say instead of me clumping all four periods together, if I were to have one distribution that was period 1, another distribution that was period 3, another distribution 5, and then the distribution 4, okay? That means that as we compare the differences, I could literally have 4 different sets. But I wanted to make sure that all of our criteria and assumption were met in this case. And we know, given two planes, okay, and given some of the class sizes, 27, we weren't going to meet the criteria. So I decided to make us one big fat distribution of statistics students comparing our planes. So let's continue on and let's look at our shape. Well, let's think back. If it comes from a normal population, everything's set. If they were nice enough to tell us that it's approximately normal or normal, that's rare. But if they tell us, thank you very much. And here, if none of those are applicable, if they just tell us that we have a sample size that's larger than 30 for both of them, then we have CLT. But please remember, CLT is only applicable with the understanding that we had randomization in the first place and then we had independent situations. Next, our center. If you think about it before we said that X bar equals mu, so here we're saying we have, as I have down here, my center, all my values. Here's one sample group, and we're saying that if it's large enough because of CLT, then my sample information can also be used as my population. Next, as we look at our spread, okay guys, ready for a formula that's kind of ugly? Bam! Okay, so here's our formula. It is also on our tan sheet. And please recognize here, this is acceptable as long as we have a legitimate sample size, or specifically, that sample cannot be more than 10% of the population. I don't know why 10% is the golden braille, but it is. Because we know if it's too large of a sample, the reality is, why don't just get a census and get it over with. What I'm about to do is find my tan card so you can see where, so pull out your tan card as I do. Let's find out where this formula is on that card. Right here, we have two sample. We have the difference of the sample mean. And here, the standard deviation, which you know is always the denominator of our hideous formulas that we have. Okay, now let's take time to answer question number 32. Please take a moment and read over the scenario. Okay, so you can see what's happening here. Let me try to expand a little. There we go. We have young men normally distributed, thank you, with the mean of 69.3, standard deviation of 2.8. The height of the young women normally distributed, again, thank you, okay, with a mean of 64.5 and standard deviation of 2.5. And they tell us we have an SRS of 16 and 9, which is really small. No one cares because they told it was normal, okay? And no one also cares that the distribution sizes are unequal, so don't worry about that. Okay, next here, the question is, what is the sample? Well, they told us it was approximately normal. So because they said here that, as I try to cover up my other answers, that both of them are approximately normal, so therefore, that means if we do the subtraction, what they have going on here, it's going to also be approximately normal. Okay, next, what's the next question? Find the mean. Well, isn't the mean just subtracting the two and keeping the same order? So the mean is going to be just the 4.8 inches. And now here's the ugliness. Find the standard deviation. So here is the standard deviation. Now please recognize they are using sigma here, and they're using it generically because you know we're about to do a t-test, and when we do a t-test, first of all, they're not going to say it's normal. Next, they're not going to use the sigma. But let's stick to what we have here. So as I look at the standard deviation, I've got this hideous formula. But what is that sigma squared? Remember that sigma squared represents that's right, the variance of the men divided by the number of men, the variance of the women divided by the number of women. Here are the values. Recognize that I had to take the standard deviation and square it because that's what represents the variance. Crank it in your calculator, and that is your output. Now, I do want to talk about the conditions and assumptions because the reality is, well, you know what? I'm going to just jump into what our whole purpose of this is, which is to do a two-sample t-test. So turn to, what page do I want you to turn to? Turn to your page 10 of your notes and go down to the bottom. What are the conditions for performing, that's real good, for performing a significance test? Well, the reality is it is the same as our confidence interval, which means now we need to go back to page 9 and let's see what they are. Okay, so here we know we have to have randomness, 2 independent random samples. We know we have to have the 10% condition. It has not changed. I wrote it down slightly different. Don't be alarmed. If you don't like that, you know you can, actually no, I did write it down like we normally write it down. Here, normality. Remember, this has to be true of both samples. And remember, if this is a t distribution, so for a t, you can have no strong skewness and no outliers. And I forgot to mention this over here, but I mentioned it earlier, okay? If it comes from a normal population, game on. Now, please remember, your thoughts should be, well, Ms. Yarbrough, how do I know whether I'm going to use a T or a Z? If they give you sigma for the population, which is rare, then we're going to use Z. But even if they tell us it comes from a normal population, but they do not give me sigma, I cannot use Z, I must use T. Now, let's go back to the next page, back to page, what page is that? Page 10. And now let's see what else we need to know about a two-sample mean, the difference of a two-sample mean. Okay, now please recognize here, what is the generic test for a two-sample t-test for the difference between two means? Well, there's your formula. Like we've seen over and over again, the statistic minus the parameter over the standard deviation of the statistic. Next, let's slide down here. What is the test statistic for the two-sample t-test? Okay, here we go. It is this ugly formula right here. And your thoughts might be, well, that's uglier than what we've seen before. I don't know about that one. But see, this is the beauty of this. You see that mu sub 1 minus mu sub 2? That's nothing but a 0 in the first place. So that's why when we do it, we might not even show that part. We might just show this part. Because it's minus 0, so why do we care? Next, please understand that this is based on the idea that our null hypothesis is the difference between the two means, and we're saying that it equals 0, or remember what equals 0 means? It means that it's no difference. And as we look at our bell curves, as we look at our HO and our HA specifically here, remember that this represents, and I should have written this down, where this is our HA is going to be greater than. This is going to be where our HA is going to be less than, and this is going to be where our HA is going to be not equal to. So if I look at, so as opposed to just being equal to here, this is what's going to change as I highlight the designated inequalities. Now let's move to the next page. And this is the end. Okay, how do I put this in the calculator? Well, take a moment, pause, and write this down, and then I will do it in the calc. Would be nice if I showed it to you. There it goes. Okay, so now let me clear out of this. Let me clean this up. I'm going to go to stat, go over to test. I'm going to go down to two sample. Again, we're doing t-test because we don't have the standard deviation for the population. And then you notice here I can go data, which means that that's when the raw data we're going to be putting in them from our L1 and L2 when that's applicable, and we will be doing that in class. Not tomorrow, but we will soon. Or here we have the stats, like tomorrow I'm going to be putting, I told you I'm going to crunch that information in the calculator, in the computer rather, and then give you guys the information for each of the planes. And then here, so you're going to be just plugging in your data. Then you're going to determine what the inequality is. And here, now this is important, we do not pool. Now your thoughts, well, Ms. Yarbrough, didn't we pool for the proportion? The answer is yes, we did. No, they didn't ask. They did it automatically. When we do this, we do not pool. So never pool. So say no to the pool. And I know you swimmers don't like that, but I can't come up with anything better. Okay, so I will see you guys tomorrow. We get to crank the information out on our little activity today. See you guys later. Have a good one. Bye-bye.